Alright, today we learned about binary ionic compounds, and the difference between ionic and the molecular is that the ionic now deals with metals and nonmetals. So, metals are usually a cation, which is something positive and it's written first. Nonmetals are the anions. They're usually something negative and they are written second. So if you take a look at the example of sodium chloride, sodium is the metal, it is a cation, and the symbol is Na+1 for the positive charge. Chloride is the nonmetal, so it's an anion, and its symbol is Cl-1. Na+1 and Cl-1 becomes NaCl, sodium chloride. Alright, there are two types of ionic naming. The first type is type 1, which means only one type of ion or one type of charge will be used. So the group 1 elements such as sodium, lithium, potassium, if you look above their symbol on the periodic tables for this class, there's a little number 1 above the symbol. That indicates the positive 1 charge, and it's positive because they are metals. Group 2 right next to it has calcium, magnesium, things like that. There's a little 2 above their symbol, so that indicates the positive 2 or +2 charge. And group 3 is all the way by the staircase. You skip the transitions. So it starts with boron, then you have aluminum, gallium. They have a little 3 above their symbol that indicates a +3 charge. Okay, so when you're naming type 1s, the first element keeps the original name. The second element changes to IDE. So you'll see that here, NaCl is not sodium chlorine, it is sodium chloride to indicate that they have bonded. And here we have some examples. Ca is calcium, O is oxygen, but the ending becomes IDE, so calcium oxide. Ki is potassium for the K, and I is iodine, but you change the ending to iodide. And then we have lithium fluoride. Li is lithium, F is fluorine, but when you combine it, it is called fluoride. Alright, now how do you get the symbols from these names? You have to look up their charges and their symbols. So cesium is Cs+1. Bromide is Br-1. And then you take their charges. We call this the crisscross method. What's really happening is an exchange of electrons, but at this time you don't need to know the reason yet. We're just learning how to put the formulas together. You will learn that later. So electrons are exchanged, which is why you see the charges moving to the opposite sides. And since they are both 1-to-1, it is written CsBr, cesium bromide. Sodium iodide. Sodium is Na+1. Iodide is I-1, and you can look these up on the periodic table or on the blue ion chart that I passed out to everyone. Na is +1, I is -1, crisscross, still 1-to-1, so NaI. Alright, magnesium chloride. Magnesium is +2. Chloride is Cl-1. Crisscross, and this becomes MgCl2. Our last one, aluminum, is Al+3. Oxide is O-2. Crisscross, Al2O3. Do not indicate any charges. It is not +2 or -2, +2 or -3. You just leave the numbers, not the charges, because they've exchanged and it is now a neutral compound. Alright, type 2 naming indicates more than one charge. These are mostly transition metals, and you will have to use what are called Roman numerals, and you have a chart in your notes with these Roman numerals, so you just have to make sure you use them correctly and are writing the correct symbol. Alright, now these are not as easy as they look. So here you have iron chloride, right? First of all, do not write iron dichloride. And Fe is a transition, and it's got many charges. And you have to indicate that charge for these. So how did I come up with this Roman numeral 2? You have to undo this formula and realize what the charges were. So here we have FeCl2. This 2 originally came from the iron. No number means a 1 that originally came from chlorine. So the original formula was Fe plus 2, Cl minus 1. So that 2 right here is indicated by the Roman numeral 2. Now the next one, oxygen, happens to be a tricky one because watch this formula. It's not as easy as it looks. If you undo this, this 2 came from lead, and this is an understood 1 came from oxygen. So we have Pb plus 2 and O minus 1. Oxygen only has 1 charge, but that charge is not -1. Okay? So this means that if there's a 2 down here, this formula had to have been doubled. So it was Pb plus 4 O minus 2 because oxygen's charge is -2. And that's where the 4 is coming from. All right, let's try a couple of these. All right, copper 1 chloride. Why is it 1? Because there are no numbers, which indicates that this is a 1-to-1 ratio. So no matter if you undo it or not, it is still 1-to-1. Chlorine's charge is a -1, so that is correct. And then we have mercury 2 oxide. Why is it 2? If you undo these, it looks like it's 1-to-1, but it's not. This is not a -1 charge, which means this formula was doubled, meaning Hg plus 2 and O minus 2. And that's where the Roman numeral 2 is coming from. Okay, now if you go in the reverse direction, how did we get FeCl3? This is coming from now that Roman numeral 3 means it's Fe plus 3. Chloride is Cl minus 1. Crisscross FeCl3. And then last we have lead 4 chloride. So this Roman numeral means plus 4. Chloride is Cl -1. This is PbCl4 because of the crisscross. Do not write the 1s. Also, at no point in your work today should you be using any prefixes. The dis and tris and tetra, that is for nonmetals only, so they should not be used today.